Hello everyone. Today we are going to start our new series on the subject grid and cloud computing. This is going to be complete series that will going to cover your entire semester subject. So before starting, let's discuss about what is the base of the cloud computing is. So the subject starts with what is distributed system is. So basically distributed system is collection of independent computers that appears to user as single system. That is, we connect multiple computer to achieve to perform a single task by distributing it on multiple machines and performing it in parallel to achieve a single task. So characteristic of distributed system is that we can able to achieve multiple process simultaneously. We can also have characteristic of inter-process communication between different processes that are running on multiple devices simultaneously. Here in inter-process communication, process can communicate with each other. Another characteristic of the distributed system is disjoint address space, where every computer we are using has its own separate memory. And one of the most important characteristic is collective goal, where we are trying to achieve to perform a task by distributing it on multiple computer. So we are trying to achieve a collective goal. Need of distributed system is geographical distribution, because as there are multiple computer or machines which are distributed across the globe, we can use all of them to achieve our task and to perform an activity which is may be difficult for single machine to do. Second one is speed of computation. Doing a work on a single machine versus doing a work on multiple machines is far easier, because multiple machines are contributing in the task. Second one is resource sharing. As we are using multiple resources, so they are also coordinating in order to achieve the task. So resource sharing is also there. Fault tolerance. As you know, in cloud computing or in distributed system, the data is on multiple systems. So we can say that the backup is already there on multiple computers. So that's help in fault tolerance. However, we will discuss in detail about fault tolerance in upcoming videos. Another is high scalability. We can add as much computer as we want, so we can expand the network of computers. Issues with distributed system. So basic issues with distributed system is, first one is transparency issue. We try that user which is using our distributed system can't able to know about that he is working on a single computer or multiple computers are working behind the scene. Second one is scalability. Our system, our resources can't be confined to only single system. We must ensure that we can able to add as much computer as we want in order to achieve our task. Openness. Openness and scalability are the related concept. In openness, we are basically can able to add new computers in our system in future if we want to expand the system. System should be fast. We try to achieve system fastness of the system. However, the problem is that as we increase the security, speed will go down. So we must try to achieve the security as well as speed as well. So another one reason is the issue we face in cloud computing is security, where let's see a small difference between distributed operating system, network operating system and distributed system. So basically in distributed operating system, transparency is high. In network operating system, the transparency is low, and in distributed system, again transparency is high. Scalability is when we can able to add as much computer as we want. So in distributed system operating system, it's low. In network operating system, it's high, but in distributed system, it's medium. Openness is we can able to add as much computer as we can. That is, the system should be as open that we can able to expand the system. So distributed operating system in terms of closed in openness is closed, and network operating system is open and distributed system is open. In terms of resource management, in distributed operating system, it's globally resources are managed by a single computer or server, and in network operating system, per node, every node manages the resource, and in distributed system as well, each node manages the resources. So main thing in distributed system is we use middleware to make multiple computer to work on a single project. So that's the characteristic of distributed system as well. For distributed operating system, you can see that supercomputer cluster where multiple computers across the globe try to do a single task. And for network operating system is like you have seen in computer lab, we have local area network. That was example of network operating system. Distributed system is everything we see where we are able to do collective task. Example of distributed operating systems are World Wide Web, that is www, social networks that we use in our daily life, peer-to-peer network, and cloud computing itself is example of distributed operating system. So let's start with one of the most important topic, that is cloud computing. So there are multiple definition for cloud computing is there. One was from Foster side, and one that the latest one from given by National Institute of Standard and Technology is also there. But we see the most basic definition that we can write in exam is, it is the model that provide on-demand access to shared computing resources over the internet. It's basically the pool of abstracted, highly scalable and managed computational infrastructure. Basically, its aim, or we can say purpose of the cloud computing is the infrastructure-less computing. That is, if we want to work on a project, we don't need to buy multiple system in order to achieve this. We can use an existing free systems as well. Second one is pay as you use, that is measured service, and we have to pay for the service we are taking from the cloud. Remote storage and processing, we are processing our data and other tasks on the remote servers. Rapid elasticity, that is we can able to expand our cloud system as by adding as much systems or computer as we can. Broad network access, that is we can able to the deal with the cloud computing resources from any of our devices. So we study cloud, we define basically cloud computing based on two models. One is cloud service model and second one is cloud deployment model. In this video we will see what is cloud service model. So basically cloud service models are divided into three parts. One is SaaS, that is software as a service, and another one is PaaS, that is platform as a service, and third one is IaaS, that is infrastructure as a service. So let's see what is SaaS, software as a service. So it's SaaS is a service of cloud computing where web-based services are provided. Basically it's a multi-tenant software over internet where user can't able to access the entire infrastructure, but can able to take the benefit of it. Like we can say that you have even used the Gmail or Google Docs, where we can able to work on an application. We are accessing the cloud in form of an web-based application. We are not given entire resource in one go, but we are working on application. So that is the SaaS, that is we have given a software. In platform as a service, we have more control than SaaS. It basically provides operating system or runtime environment. Basically it's like development platform, like Google App Engine, where we can able to develop the apps. So we have been provided with a platform where we can able to develop an application. In infrastructure as a service, it's more broader than SaaS and PaaS. Here we have been provided with the virtual machines storage, that is we have given the access to infrastructure. So definition wise we can say that it provides virtualized hardware resources over the network. It's more powerful and more control has there than SaaS and PaaS. In next video we will see what is cloud deployment model. So in previous video we have seen cloud service model. In this video we will see cloud deployment model. So service model gives the information that how much control we take on the system in the cloud. In deployment system we discuss about who owns the cloud. So on the basis of deployment, it's divided into 4 parts, that is public, private, hybrid and community. A public deployment model consists of the cloud which can be accessed by everyone. The example of is AWS. Basically it's owned by third party organization. Here one have to pay as per the uses they make. In private deployment model, it's accessed by single organization. It's like bank servers which can be only accessed by an private organization only. There is only single organization who owns it. Here basically resources are confined, that is only the resources which are available in the private environment one can able to use. Hybrid version is the mix of public and private deployment model, where basically mix of public and private cloud is there. For example, bank plus cloud, like you have used UPI apps where some data is being publicly shown, however the bank details is kept as a private server. In hybrid hybrid deployment model we face cloud bursting as well, where a organization you try to use their private cloud for making work. However, if the demand increases, the workload increases, then the load will be transferred to public cloud. In community deployment model, multiple organization or groups with the similar interest or requirement share the cloud environment. It's like hospitals and banks, like multiple hospitals share the research paper or medical informations over the common servers. And similarly like RBI in India owns the multiple bank servers. So that's the thing we have seen in deployment model. Hello everyone, in this video we will discuss about the characteristic of cloud computing. So one of the main characteristics, on demand self service, that is user can able to take the service whenever they want. Second one is broad network access to all devices, that is the cloud can be accessed from any of the devices, either from your mobile phone or from your laptop or computer. Resource availability to all, everyone can able to get resources whenever they want. Rapid elasticity, where cloud can able to manage the high workload or low workload simultaneously. Measured service, basically whenever you take service you have to pay for it, that is more service you take, more you have to pay. Improved performance of local system, as local system have single resources, so sometimes it may hang, but if you will perform a task on cloud computing, the servers are more powerful enough that they can able to easily handle the task. Lower cost for users, as instead of buying the entire infrastructure, if one can able to use the online systems provided by cloud, it will be much cheaper. High performance due to powerful cloud servers, the cloud servers are powerful enough that they can able to achieve even a complex task we find it on our local system. Cloud storage is almost unlimited or unlimited is almost more or unlimited compared to local device. That's thing. Data reliability is also there, as the data backups is on multiple servers, so the data reliability is there. Provide device independence, and so you don't have to confine yourself to use it on mobile phone only or laptop only. You can do work from any of your device on the cloud computing. Disadvantages of cloud computer include security risk, where there is always the chance that the cyber attacks may happen on the cloud servers, so there is chance of security risk. Data loss risk, like if you are transferring your file from your computer to the data centers, then there may be data may be lost, or someone steals in between. Internet is required, so if you have to use cloud servers, you need internet compulsory. Vendor lock problem is also there. That is the one of the main reason that is a disadvantage of cloud. That is, if you are on one server, one platform of cloud, then you want suppose to switch from that cloud to another cloud company or platform, then their orientation or their coding base, everything is infrastructure is different, that you can't able to shift directly from their server to another server by taking your data from there to there. That will be difficult, so that's the vendor lock-in problem. So as in previous video, we have seen cloud computing provide cost-effective solution, servers, scalable and high availability. It also provides storage and computing resources. So today we will see what is CSPs are, that is cloud service provider. These are an organization that provides cloud computing services such as storage, computing and networking over the internet. So the problem they face are uncertain workload. That is, sometimes the workload will increase rapidly, or it sometimes decrease. So the main problem they face is like over provisioning, where in peak load they require more servers to handle the workload, and they sometimes face underutilization as well. That is, when the servers or infrastructure is more but demand is and utilization is less, so in that time server remains the idle. That is the wastage for them, and it results in loss for them. Their aim is to maintain quality of service, where they have to offer best service to their users. So they have to maintain a quality of services as best as they can. Second one is they must have to comply with the SLA, that is service level agreement. Like for example, while buying the service, the user and the CSP make agreement that for 99.9% their server will be uptime. So the CSPs guarantee it to their users before user make purchase their service. So as we discussed about CSPs in previous video, we have seen that they face problem of over provisioning, where during the peak load they require extra servers to handle that workload. They also face underutilization, where they have more infrastructure but demand is less, so in that time servers remain idle. So these problems are solved by the Cloud Federation. So let's see what is the definition of Cloud Federation. So Cloud Federation is basically the collaboration of two or more cloud service provider to share computational resources in order to improve their performance, quality of service, availability, reliability and profit, while considering trust and fault tolerance. So multiple clouds here are working together to tackle the extra workload they are facing. So benefits of Cloud Federation is multiple CSPs are there, so there is more support to handle the workload that is coming on the particular CSP. Resource sharing is there, better quality of service is provided to the user, more reliability as system there is less chance of system failure, and data is already on multiple servers as a backup. More profit can be expected as in underutilization, where server is idle for one CSP, it's being utilized by another CSP, so one that was idle is no longer idle again. It handles high workload. There is fault tolerance features. In cloud federation or in any of the service provided by cloud, we have listened about the term quality of service. So what is quality of services? So quality of services, the cloud should be providing the fast response, there shouldn't be any delay, and good performance should be there. So to understand the federation concept more clearly, we have to know about some terms which are important. One is satisfaction level. It measures how much CSP is satisfied in a federation based on availability and profit they make. Second one is availability. That is, it availability increases in cloud federation because multiple CSPs provided independent backup resources. Cost and profit. Higher availability means higher price. Since extra backup servers, extra storage and extra power are required, so high prices are there for making the high availability and to achieve higher quality of service. Trust. It measures how reliable a CSP is in delivering the promised quality of service. So these are the main terms about the cloud federation that you must know in order to understand it. In next video we are going to start with game theory in federation. As most of you have used virtualized computer in your Windows on VirtualBox, so today we will see what is virtualization is. It is creation of virtual version of hardware, operating system, storage or network resources. A single real computer can have multiple virtual computers. So virtual machines is software based computer that runs like real computer. So you have used multiple virtualized environment in your VirtualBox where we create multiple operating system and can able to work on them in single computer. So have you ever thought about who creates these virtual machines on a single computer? The one hero is here, hypervisor, that creates the virtual machine on the system. It is a software layer that allows multiple virtual machines to run on single physical machine. So let's see that it's hardware, that's your normal real computer. Here hypervisor creates one or more virtual machines. Hypervisor here controls CPU, RAM, disk and network. So now we are starting with the game theory in federation. So let's see what is game theory is. So coalition game framework where multiple players form a group to achieve a better benefits. That is, multiple CSPs form a group in order to achieve better benefit. Here player is CSPs, that is cloud service provider, and group in which the players are going are federation where CSPs are joining. So in game theory these two terms are very important: transferable versus non-transferable utility. Transferable utilities are the utilities that one can able to share, like money or resources, which benefits they can share. A non-transferable utility is like happiness, satisfaction level or trust. These are not transferable. In game theory we also study about hedonic correlation game where based on trust, profit, availability and satisfaction, in the satisfaction the player decide which group to choose. Here utility depends on group involved. It helps in to choose trusted CSPs and high profit CSPs and high availability of CSPs. In coalition game basically the aim is to achieve the stability. So three properties of stability we will see is: one is convergence, that is system is finally stable and the groups that is the CSPs who are there in federation can't change group again and again. Nash stability, where we can say a coalition is Nash stable if no player can improve its benefit by moving to another coalition. One of the another term is individual stability, where a player moves to another group only when both itself and coalition are benefited. So have you ever thought why stability is important in federation? If a CSP changes the federation again and again, the system will become slow. That will affect the quality of service, and it also result in profit loss. Now we will see the fault tolerance in federation. Fault tolerance is required in cloud federation to maintain availability and reliability when failure occurs. Basically, fault occur in the CSPs is because of high utilization of resources that results in high temperature rise on the server side that increases the fault occurring probability. So what federation will do if fault occurs? So faulty servers on when they occur with fault, they send their virtual machine that they have on another server. This will require migration cost, that is sending a virtual machine from one server to another. Basically aim of the CSPs are in the federation is to gain high profit with low migration cost that will decide their quality of service. So while forming the federation, the factors one CSP has to consider is, one is profit. CSPs must ensure that higher profit they have to earn. Quality of service, that is they can able to achieve high quality of service towards their user. Trust, the CSPs would be trusty enough that their federation can able. Hello everyone, now we are going to start with a new topic, RPC, remote procedural call. So before starting, let's see what caused the need for RPC. In distributed system in earlier times, they used old method like socket, where socket was a low level network mechanism which was used to connect other different machines to send data between the distributed system. In the socket, the main problem was access transparency is not there. That is, user can able to easily able to understand, or they can see the symptoms that they are trying to work on a project. The aim was that they can feel that the environment is not distributed, but the access due to absence of access transparency, the user can able to see that the distributed system is behind the scene. So that was not there. So solution came with RPC that allowed a machine to. So RPC was, that is remote procedure call, was the mechanism which able to gain the access transparency. So RPC is basically a mechanism that allowed a process on a machine to call a procedure on another machine as if it was a local machine call. Here, when the client side or the user who is calling the process, then calling procedure is suspended when the client makes the request, as this request go to the remote machine for execution. Then remote machine will execute it and return the response back to the calling procedure where it was called from user side. So we will see in detail about it how RPC really works. Before starting RPC working, one of the main term you should know is stub. So stub is a helper code used in RPC that converts procedural call into message and message into procedural call. So in RPC there is a client stub and server stub which are connected through network. Client stub packs the parameter in message and sends it to server and wait for reply from the server. When client sends the parameter packed message to the server, it receives the message and it unpacks it to load parameters. in its database, then real function happens on the servers, and then the result is again being packed in a message and sent back to the client stub. So stub hides the communication, that is user can't able to know that all of thing is happening behind the scene on the server side. So this is the detailed steps of RPC flow, where client program function makes function call on the to the server. That function call from client side goes to the client stub. Client stub makes the packing of parameters in a message. This is known as the marshalling. That is, this process is marshalling. Client OS then sends this packed message to the server. Server OS receives the message and send it to server stub, and then after the server stub unpacks this message. This is process called unmarshalling. Server now execute the real function call on its server side and execute it. Server returns the result to the stub, and stub again packs it in the message and returns it to the client OS through network. Client OS unpacks it and give the result to the client. Issues we face in RPCs are transparency issues. RPC tries to provide transparency, but complete transparency is difficult due to network communication. That is, there may be lag or any hang between the network, so complete transparency can't be achieved. Parameter passing issue, where pointer based parameter passing is difficult in RPC because client and server have different address space. So directly passing parameter to server side can't reference it to the client side, because only the data requests are being sent, that is, address is being sent to the data, not the data itself. So that's the issue in parameter passing. Heterogeneity issue. RPC must handle heterogeneous issues like different operating system may be there on client side, different CPU they are using, different data is there between different system, and client and server architecture may be different. Failure issues can also occur, that message may be lost, server may be get crashed, client may be crashed, or reply may be lost. Performance issue may be also there, that RPC is very slow because of marshalling and unmarshalling process. Security issues are also there, that is, there is chance of hacking, fake servers, fake client. Required authentication and encryption to achieve this security issue. Let's see about some of the issues in RPC. First, see parameter passing in RPC. So in parameter passing, sometimes we do call by value, where values are copied into message as a parameter and sent directly to the server. But in the previous video we have also seen that call by reference, where we pass the pointer address, doesn't happen easily in the RPC, because only transferring address doesn't give the data itself, which is like address you have given to server, but the actual data is on the address on the client side database, so server directly can't able to access it. So for dealing with that problem, it copies the entire data which is being referenced from the client side, and instead of sending pointer, it sends the entire data in message buffer to the server. Another issue we have seen in the previous videos was heterogeneity issue in RPC, like byte ordering, that is, data may be different. Heterogeneity is there, that is, data different, like one encoding is used by little endian and another encoding used by big endian. Little endian and big endian concept we will cover in our digital logic part. So because it's a theoretical lecture, so we can't directly dealing with the mathematical aspects, but in little endian, in LSP, the least significant bit, like here you can see 4 comes before, least significant bit in little endian comes the first. In big endian, the LSB comes in the last and MSB comes first in the encoding. Another issue was data type size problem, that is on older system, for example, integer was of 2 bytes, but in new system it's now 4 bytes. So that heterogeneous issue is also there. Floating point format problem, where different system use different format, like some use decimal but some use binary. Character set problem, some system use ASCII encoding whereas some use UTF encoding. So solution to handle with the heterogeneity was finded as to use standard encoding like XDR or XML. So here we are starting with a new topic in the RPC, that is binding. So binding is basically connecting client to server before making any communication between them. There are two types of binding is there. One is static binding and another one is dynamic binding. Static binding is using hard coded server address from where client use a hard code address of the server in order to make communication with it. But the problem in static binding was server, suppose if server is moved, then changes to the address or replication is required on all programs that they have the address of the server. Everywhere we have to make changes. So the solution came is with dynamic binding, that is assigning address of server on runtime. Here instead of using direct giving direct hard code address of the server in the execution, basically this happens. See, when the server starts, it registers its name on the binder. When client have to contact with the server, it look up name on the binder, then binder returns it with the server address in runtime. Then after server gets the client gets the address of server, they make RPC call as the connection between them is established. So you have seen that dynamic binding is more convenient than static binding. So that's it. So now let's discuss about one of the issue in RPC, that is failure in RPC. So now we see different types of failures that occur in RPC. One is server not found, another is message lost, second is server is being crashed, or third is client crash. So server not found failure occurs when the server is down, or either wrong binding address is returned, or network problem is there. Solution for this is using exception handling or error, returning error to the client side. Second one is message lost. If the message is lost in between the path, then the solution is retransmission of the same message and ensuring that duplicate message is being detected, so that no two duplicate messages goes to the client side. Another one is server crash, that is server is being crashed. So these are of three types, at least once, at most one, exactly once. So that is not much important. Main thing is on client crash side, where client when send the request to the server, suppose it has executed it has sent a request to server and it's rejected or it's destroyed. On the client side, process is being destroyed. So in client crash, if client send a request to server to execute a task, and suppose server start executing that task, but client crashes, so this results in creation of orphan process, because the process running on the server has no longer any parental process for which the server is working for. This causes the CPU wastage in the server side and locked resources. So this is the main concern in the client crash. So for solution of orphan process, basically three methods are used. One is extermination, where client reboots itself and send a message to server asking it to kill all the orphan process of the client. Second one is reincarnation. New epochs were created by the client and broadcasted to inform the server. Third one is expiration, where assigning a time limit to RPC request, after which orphan process removed. That is, after a particular time, if the no response came from the client side, the server will automatically expire the process.